Welcome to the SI Academy. Today we're starting about the class 9th chapter number 1, matter in our surroundings. So in previous class we discussed that the nature of the particles given by two methods. One is particles are matters are two types. One is the scientists are said that matter is continuous particles. Another, they are blocks. They are given by the two different kinds of statement given by the different types of scientists. One type of group of people or group of scientists said that matter is nothing but it is a continuous particle. Another scientist said that matter is nothing but there are what blocks like sand particles, they are said. And the nature, and also said that matter is occupies the space and volume, they said. Okay, these are the some points we studied in previous classes. Okay, next we will study about how or what is the exact size of the particles of a matter. So for that we having one activity, so that you have to done means we can easily understand the size of the particles of a matter. Take 2-3 crystals of potassium permanganate and dissolve them in 100 ml of water. We have to take a potassium permanganate. KMnO4 is called as a potassium permanganate. We have taken potassium permanganate, that is the chemical formula of potassium permanganate is KMnO4, and it is dissolved in 100 ml of water. Okay, so we have taken potassium permanganate. This is the chemical formula. This is the potassium permanganate dissolved in 100 ml of water. Okay, after that so small here information is given here. The SI unit of mass is what? Kilogram. Remember that the SI unit of mass is kilogram. Kg. The SI unit of mass is kilogram, and the SI unit of volume is cubic meter. So the SI unit of mass is kg, and the SI unit of volume is cubic meter. The common unit of measuring volume is liter, such that 1 liter is equal to 1 diametric cube. So 1 liter is equal to 1000 ml. Okay, so what is here the common measurement of liters? It is measured in what? 1 liter is equal to how much? 1000 milliliters. Okay, 1 millimeter is equal to 1 centimeter cube. Remember, 1 liter is equal to how much milliliter? 1000 milliliter. Okay, in 1 liter how much milliliter is there? 1000 milliliter is there, and 1 milliliter is equal to 1 centimeter cube. Remember that. What are the units here? First, SI unit of mass is a kilogram, and SI unit of volume is cubic meter, and 1000 liter is equal to 1 liter is equal to 1000 milliliter. 1 milliliter is equal to 1 centimeter cube. Remember, these are the SI units. Okay, they will useful in your higher education also. Take out approximately 10 ml of this solution and put into 90 ml of clear water. First you have taken potassium permanganate, correct? In that we are in potassium permanganate is added in 100 ml of water. When these two mix completely, from this solution you have taken only 10 ml of this solution, and we are adding to the what? 90 ml of pure water or clear water, and you have to add this. Take out 10 ml of this solution and put it into the another 90 ml of clear water. Keep distilling the solution like this 5 to 8 times. Is the water still colored? Okay, this is simple experiment what they are saying that. So first you have taken 100 ml of clear water. In that we are adding 5 to 2-3 crystals of potassium permanganate, KMnO4, right? So we are taken a clear water of 100 ml. In that we are adding 2-3 drops of potassium permanganate. After that this 100 ml of water is completely mixed with the water plus potassium permanganate. After this, in this solution we have taken only 10 ml. From this solution we have taken only 10 ml. From this solution we have taken only 10 ml, and this 10 ml is again added to the pure 90 ml of water. So we have taken from 100 ml of this, it is completely mixture without water as well as the potassium permanganate. From this we have taken only 10% of this solution and added clear water, only water of 90%. Again 90 plus 10, again it becomes what 100. So it is 100% solution. Okay, that of what contain 90% of water, 10% of potassium permanganate. Okay, after that from this solution again you have taken 10 ml of this solution, again this added to the again 90 ml of pure water, again we are added in this, again we have mixed it. So after that from this again 10 ml of solution is taken here, and this is added to the clear water of 90%. Okay, so this experiment is done for 8 to 9 times. After that what we conclude, and still the color of the water changes. So here first the color is what, blue color, blue shaded color. After that the color is changing, how it is adding the potassium crystal to it. So how many times still the color of the water will be changes, that you have to observe here. Estimating how small are the particles of matter with every dilution. Dilution means mixing of water with any kind of substance are called as what, a dilution. So any substance or any solution that mixed with water is termed as what, dilution. So dilution means a mixing of water. That is simple meaning, dilution is a mixing of water. Through the color becomes light is still visible. Okay, how we are adding the water to it, so it is visible and it is showing the color. What this experiment suggests or shows means, this experiment shows that just a few crystals of potassium permanganate can color a large volume of water. Okay, so about 1000 liters. Okay. So for example, a small crystals of potassium permanganate giving a color to the large volume of color to the water. For in the above activity, the total water is how much, 100 liter, correct. In that we are adding only 2 to 3 crystals of potassium permanganate, because here we can observe carefully, means here the content of water is largely more compared to the content of potassium permanganate. Only 2-3 crystals of potassium permanganate is taken as a 2-3, but here the water is taken 1000 ml, right, 1000 ml we have taken water. So here in this experiment, this is the experiment, we have taken only 100 ml of water. In that we are adding 2-3 crystals of potassium permanganate. Still the water having the more concentration, but the potassium permanganate is very small in concentration. Still it is mixing with the water and giving the color to the solution. So this means the particles of a potassium permanganate is mixing with the water molecules, means they are having a space between them. So this conclude from this activity we concluded the particles having a space between them. So that is why they are mixing with the water particles. So this is the first point from this activity we derived. So we conclude that there must be a millions of tiny particles in just one crystals of potassium permanganate. Okay, so one crystal of this is the small crystal. Okay, this crystal contain millions of tiny means very small particles. Okay, so this one single crystal contain a millions of tiny particles of potassium permanganate, which keeps on dividing themselves into smaller and smaller particles. Okay, a small crystal a small crystal contain millions of tiny particles, and when again the tiny particles again divided into smaller and smaller particles. So they are divided themselves as a smaller and smaller particles. This is the reason why the water is changing its color, because that particles are again divided into smaller and smaller particles. The same activity can be done using 2 ml of Dettol instead of potassium permanganate. The smell can be detected even on repeated dilution. Okay, for example, again we are not only the potassium permanganate, other particles also gives the smell. For other also particles can divide further. For example, while cleaning the house or while cleaning while cleaning in hospitals, they they will take the full bucket of water. In that they are adding only one booch of or one spoon of Dettol, and they are cannot adding full of bottle. They are adding only one spoon of the Dettol solution, so that will provide cleaning as well as they will provide the smell. So this is the example. So means the particles again are dividing into smaller and smaller particles. So for example, in your home, your mother is cleaning the house, means she will take a full of bucket of water. In that they are adding only one drop or two drop of Dettol, so that cleans the house. So they are not adding completely full of bottle of solution, so they are adding only one booch or two spoons, so that enough for the cleaning the house. Because the particles are again dividing into smaller and smaller particles. From this experiment we suggest that or we conclude that the particle size is very small. We cannot imagine that how much, means when we have placed this point, so this is the large size compared to the size of the particle. So the point size, so this is the larger compared to the particles. That much they having very small, so we cannot imagine it. That much they having very small size. Okay, particles of matter are very small. They are small beyond our imagination. We cannot imagine that. So the size of the particle, that much they are having very small in size. Next, again very important topic comes here. So characteristics of particles. Characteristics of particles. In your exam definitely they will ask, write the properties of matter. Okay, right, or write the characteristics of particles of matter. Okay, so particles of matter have a space between them. First point is have, what is the first point? Particles have space between them. Okay, what is that meaning? Means in activities 1.1 1.2 we saw that particles of sugar, salt, Dettol or potassium permanganate got evenly distributed in water. Okay, so for above activity we conclude that we have taken 100 ml of water. In that we are adding only 10 ml of potassium permanganate, right? Potassium permanganate, that is continuously dissolving in it. So means they having KMnO4. So this is called as the potassium permanganate. It is dissolving in 100 ml of water. So 100 ml of water. So it is evenly distributed in the 100 ml of water. Even we can take sugar, salt, Dettol, all are completely dissolving in the water. Similarly, when we make a tea, coffee or lemonade, nimbu pani, particles of one type of matter get into space between the particles of another. Okay, whenever you are mixing the two types of substance or in a substance into the another solution, means the substance will take the place between them. Okay, means this they having the space between them. That is why they are mixing completely. They are not having the space, means they will not mix up. So that is the examples of what when we make a tea, coffee or a lemonade. When we are adding a lemon to the water, they will mix up with the completely. We cannot separate the lemon and water. Again, when we make the tea, so we cannot separate the water and milk. Again, we cannot separate the coffee also. So we cannot separate the milk and water. So because they having this space between them, they entirely mix with each other. So that is called as what? They having space between them. We can give the several examples: coffee, tea, lemonade, soda. Okay, we can call it as nimbu pani also. So and water and sugar also, that is the example. And water and salt, that is the good example. They are completely mixing with each other because they having space between them. So there is no space between them, means they will not mix up it. This shows that there is a enough space between the particles of matter. This shows that they having enough space between the particles. This is the first point. Next, particles of matter continuously moving. First is what? First point is what? Particles are having a space between them. Second point, particles are continuously moving. What is the continuously moving means? Also, for this understand, you have to again do the activity, that is activity 1.3. Put unlit incense stick in a corner of your class. Okay, how to take incense stick? Incense stick means we can say that agarbatti, so that when we are going to the temple, we are taken that prayer for that agarbatti, that is called as what? Incense stick. So how to burn a incense stick at the corner of your class? How close do you have to go near it, so as to get it smell? How far you go, or how near you to go to that incense stick to get a smell? This is the question. How means when what is the when we are going away from the incense sticks, still we are getting the smell, or we are how to go near to this that incense stick, that time it will giving the that smell. So that is the question here. So now light the incense stick. What happens after that? Placing at the corner, and you have to stick it. So stick it means it will burn. It means it will smells or not. Do you get the smell sitting at a distance? We are burning the incense stick at the corner, and we are sitting at the another corner. Still we are getting the smell of that. You have to observe. So this is this simple experiment. First, what is that? What is activity 1.3? We have taken a simple incense stick, and we burned the incense stick at the corner of the classroom, and we are sitting another corner. So in that we are smelling that incense stick or not. How to observe that? Okay, this is a simple activity. Another, take a two glass or a beakers filled with water. Again activity 1.4 is there. We have to take two glasses or a beakers with filled of water, right? Put a drop of blue or a red ink slowly and carefully along the sides of the first beaker, and honey in the same way in the second beaker. Okay, what we have taken here? We have taken two beakers or two glasses. In that first we have taken two beakers. In the first beaker we added the water carefully along the first we added a red ink or a blue ink. Okay, first we have what we added here. So first we have taken two beakers. In that we are added red or blue ink, correct? In second we are added only honey. So second beaker added honey, red or blue. So second we are added in the that beaker is honey. So first beaker red or blue ink, second honey. Leave them undisturbed in your house. So leave them undisturbed means we cannot touch it, or we cannot shake that two beakers. So we have not touched the some time. So leave them as it is. So that is called as the undisturbed, or in your corner of the class. Okay, in your home, or as well as here you are doing this activity in your home means, so they will left for 10 or 15 minutes. You are doing in a classroom means kept in that corner of the your class, and don't disturb them. Okay, don't disturb that. Record your observation. What do you observe immediately after adding the ink drop? Okay, after that when you are adding the ink or red ink or a blue ink to that water solution, so what will happen? That you have to observe. What do you observe immediately after adding a drop of honey? Again we have to observe what happens to the water when we are adding a red ink or a blue ink to it, and another beaker we are adding honey. What happens to that water solution? We have to observe here. How many hours or days does it take for the color of ink to spread evenly throughout the water? Next question arises here. How many hours or how many days is required by the ink to spread out throughout the water? This is the question. Next activity, they are simple activity. Drop a crystal of copper sulfate. Copper sulfate means CuSO4, right? This is the copper sulfate, and potassium permanganate. Already you know that. What is the formula? Okay, we can say that Okay, correct. That is the KMNO4. You can always write M below side. Okay, don't write here on this beside. Okay, you have to write on below always. Okay, that is potassium permanganate. Okay, KMNO4, right? One is copper sulfate. Second is potassium permanganate into a glass of hot water and another containing cold water. Okay, the potassium permanganate is taken in a cold water and another is what, copper sulfate is taken in cold water and potassium permanganate into copper sulfate is taken in hot water and another one is taken is in a cold water. Do not stir the solution. Do not stir means you do not mix. Okay. Stir the solutions. Allow the crystals to settle at the bottom of the container. We have taken a container, in that we are adding a solution with copper sulfate or a potassium permanganate. We do not stir it, so do not mix with any kind of materials. Why means the particles should be settled down at the bottom. Settled down means they will settle at the bottom or they will store at the bottom. That you have to care should be taken here. What do you observe just above the solid crystalline glass? Okay, what we are observing at the solid crystal in the glass? What happens? The time passes. What does this suggest about the particles of solid or liquid? Does the rate of mixing change with the temperature? Why and how? So as the time goes on, the temperature also changes. So while temperature changes, the mixing of the particles also changes or not, that you have to consider here, or observation you have to do. From above these activities 1.3, 1.4 and 1.5, we can conclude the following results. Okay, from the first activity, incense stick, again adding the honey and red ink or blue ink to the water solution. Another one is what, potassium permanganate and copper sulfate solution. So what will, from these two activities or three activities, what we conclude here? Particles of matter are continuously moving, that is they possesses what we call kinetic energy. Okay, first from these three activities we concluded that the particles of matter continuously moving, that is why the smell of the incense stick is passing from one corner to the another corner. That is why when you are in your home, your mother will making a tasty food, means you are sitting on the hall, we can smell the taste of the food. So why means the particles of the food are traveling continuously, that is why you are smelling that food. So that is the simple example. So first point, what is the particles of matter continuously moving, that is the possesses, they are moving means they always possesses which energy? Kinetic energy. The object or that particles are moving, that always possesses which type of energy? Kinetic energy. What is kinetic energy? The particles which moving, that always possesses energy. That energy is called as kinetic energy. As the temperature rises, the particles move faster. Okay, as the temperature rises means particles also move faster. Particles are moving means again the kinetic energy also increases. So we can say that with the increase in temperature, the kinetic energy of the particles also increases. What is the point here? First point, particles are continuously moving. Particles are continuously moving and they are moving means possesses which energy? Kinetic energy. As the temperature increases means kinetic energy also as the temperature increases, so kinetic energy also increases. Kinetic energy also increases means particles also move very fast. This is the point. Okay, remember that. First point, what we said, they are continuously moving, right? They are continuously moving means they possess which type of energy? Kinetic energy. So as temperature increases means kinetic energy also increases. Kinetic energy increases means the particles move fast. This is the simple topics from this activity. In the above the three activities, we observe that particles of matter intermixing on their own with each other. Okay, from the above activity 1.1, 1.2, 1.3, so they tells about that the particles of two different particles mixing with their own. So they are not ordering we are not ordering them to do. We have to mix with in a particular condition, particular ratio. They are mixing with their own. Okay, so for example, we are not saying that the sugar and water to mix with each other, and we are cannot saying that mix the water with we are cannot saying that sugar is mixing with the water. This is they are depending on their own, they are mixing with one another. They do so by getting into these spaces between the particles. How they are mixing? While they are mixing, because of the having space between them. This is the second point. First is continuously moving, and they having space between them. This intermixing of particles of two different types of matter in their own is called as a diffusion. Again, very important 1 mark definition. What is the diffusion means? We can write the intermixing of two particles of different types of matter on their own is called as a diffusion. The intermixing of two particles of their own, they are mixing two different kinds of particles are mixing with each other, but depending on their own is called as what diffusion. For example, again we can give the sugar plus water, sugar plus again salt, water plus copper sulfate, water plus potassium permanganate, water plus ink, red ink, blue ink. We can take any one, another water plus honey. We can take several kinds of substance. They having always different kinds of matters or different kinds of substance. They are mixing with own. That is called as the diffusion. We also observe that on heating, diffusion becomes faster. Okay, so again on heating, again it will the particles move faster, because heating again produces the energy. That energy is again moves the particles means again kinetic energy means particles moves very faster. Okay, that is the reason if heat also given means the particles also move, because they possesses kinetic energy. Okay, thank you for watching, and in next class we will study about the particles of matter attract each other. So thank you for watching. Please subscribe my channel and share and comment also. Thank you.